from the American and southwest down into Mexico. They actually range as far north as like south central Utah. There's two different subspecies. Kind of the main difference is the coloration pattern. And if you look at this, you can see why. But a lot of like Native American bead art and stuff is inspired by these guys. Just lay low so that to avoid desiccation and that type of thing. And they can go for months without eating. Then when the monsoons and stuff come in the late summer and fall, they come out again and build up a bit of a reserve for the winter. And my favorite thing, a little bit about their venom. They have what some biologists would call a fairly primitive venom delivery system. They really don't have. You think about snakes; they have like basically syringe-like fangs that almost act like hypodermic needles to inject the venom. These guys they just have grooved teeth right above a venom gland that's in their lower jaw, and so they bite. It exerts pressure on the venom gland, and then the venom just oozes down the outside of the tooth, down the groove into the. So they kind of have to gnaw the venom into the prey. And there's some cases, some reports that if they really need to deliver a lot of venom, they'll actually flip upside down, since it's flowing from across the grooved teeth, flip upside down and get it to flow into the wound a little better. And the cool thing, I think, my favorite story about these guys is someone got the bright idea. They said, "Hey, these guys are only eating every 3 or 4 months potentially. How are they maintaining those blood glucose levels constant between meals?" So they looked at they actually found a protein in the venom. I think it's called extendin-1, and it basically is really similar to a hormone we have. I forget the name of it, but it basically regulates insulin and glucagon levels in the blood. And so they were able to make a synthetic version of that, and they marketed it as Byetta, and it's what's used to treat type 2 diabetes in humans. So kind of a cool example of how venoms can be used to develop pharmaceuticals that can help people.
Belly scales for movement along. And one thing I like about this one, this is a Colubrid Snake. So most in that family are harmless to us. This one is rear-fanged. What I mean by that, they have certain families within Colubridae have enlarged teeth at the back of their jaw, which help with delivering venom. And this snake is mildly venomous. But as Eric said with the Gila, it's not as developed as a venom apparatus as compared to your cobras, your rattlesnakes, which have that hypodermic in front. These will have either just a large tooth, a grooved tooth. Some have almost a complete hypodermic, but it's a little less developed. However, a couple, such as the boom slang, has a very well-developed venom delivery system and very potent venom.
And that's in the same...
That is still within the same family. So, one nice thing with these, like I said, South American, but a lot of the natives love to have these around because, like with other snakes, like rodents, but these like to eat snakes. So this one specializes in things like the fleur-de-lance, lance-headed vipers, very big problem in South and Central America. And rattlesnakes, these guys will eat them up all day long. They love them. They're immune to the venom. So people go out in the wild, catch them, bring them into their farm, hope they'll stick around and try to keep the venomous snakes out of the way.
Are the king snakes?
Now he's being a cobra, kind of. It's actually in shed. There we go. That's better. He really just wants me to scratch him on the head. No, he doesn't. Huh? How about that? Anyway, cobras don't have those real long fangs like lapids, like vipers and pit vipers. They have really short fangs. They're in the front of their mouth. They're not nearly as effective, you would think, but they make up for it in a unique way. Most of their venom is really small peptides. A lot of it consists of 3-finger toxins. Literally, it looks like this. It's shaped like this. And it's 44 or less amino acids, and that stuff goes through your body really fast. So you have a snake like a viper or pit viper, they have these large metalloproteinases. They're kind of slow moving, so they need the spreading factors and other things. But the venom is injected really deep. Here the venom's not injected really deep, but they're really small peptides, so they get through really, really fast. And that's what makes the difference with these. It's interesting, though, that for treating snake bite, like from one, if you get bit by this here, you're probably going to live through it because we have anti-venom all over the U.S. for these things because so many people keep them. Where they come from, because the third world countries, you can't get the anti-venom. Most of the kids, usually children, walking to the restroom at night end up getting bit and dying. And it's sad. In fact, the World Health Organization and a few professional authors have just started writing on this and saying, hey, we need to do something about this inequity. Why is it that you can have a snake in the U.S., get bit and go to the hospital and get anti-venom, but if you live where it comes from, you die? It makes no sense. But that's a sad economic reality. That's just the way it goes. See, he likes me. He just wants to give me a... You want me to scratch on the head? Here, I'll scratch on the head. Venomous snake. They come from the outback of Australia. And with the venom works in a lot of unique, wonderful ways. One thing, it has a vasodilator, so your blood pressure drops. Then there's another part of the venom is making your aorta and all your arteries nice and leaky. And another part of that venom is using up all your coagulants so that you bleed from everywhere. And just in case you don't drown in your own blood, it has the most powerful presynaptic neurotoxin on the planet. But that's okay. If a little acetylcholine gets out, it also has a very powerful postsynaptic neurotoxin. So it's kind of like being beat up by the whole baseball team all at once. Now with venom that toxic, it can eat things that other snakes cannot. And one of those things is plague rats, which is kind of a nice thing. If you happen to live out there, you're probably not too fond of plague rats. And the other thing it can eat is bandicoots, which prey on snakes, but not this one. Eastern Texas, all the way into Coachella Valley, California. South into Mexico, north up into southern Nevada and stuff, so it has a very large range. Over most of that range, they get fairly large. They're very nervous snakes. They're apt to bite, and they're going to deliver a lot of venom, okay? They are pit vipers, so in the darkest of night, they're still getting that 3D infrared image of you. So that makes them a pretty dangerous animal all around. Most of the snake bites in the U.S. every year are caused by this animal. I want to talk a little bit about some myths and stuff around rattlesnakes. One thing is the idea, and you've probably heard this, that you're in a lot more trouble if you get bitten by a baby rattlesnake than a big one because they can't control their venom. Well, if you do a little common sense test, you can really think this through. Would you rather be bitten by a snake with a head the size of a dime or a grapefruit? Just think about that a minute. It doesn't take a whole lot of effort to figure out. Number two, if a baby snake couldn't meter its venom and it went to bite a lizard, and the lizard ran off and maybe a bird got it or something, what would it do then? Starve? That doesn't make any sense whatsoever, okay? And for my ticket, I will take the dime-sized head over the grapefruit-sized head anyway, because that grapefruit-sized head has more venom in the fang than the whole other snake does, you know? So the other thing I want to talk about is the idea of the rattle having poison, fairy dust, beads, whatever it is in there. It's actually just loosely interlocked segments. It's vibrated at a high speed, and actually it's the fastest vertebrate movement on the planet, and they can do it for up to 3 hours without fatigue. You know, most of us can't run around this building without fatigue. So it's pretty impressive for a cold-blooded animal. You can't tell the age of a rattlesnake by looking at the rattle. For one, people say, you know, that each segment is a year. Well, baby snakes may shed 4 to 5 times a year, and every time they do, they're going to add a segment. An adult may only shed once every 2 years, like in the northern ranges of the timber rattlesnake, northern Pacific, stuff like that. So it's not going to be an indicator. After they get about 6 to 8, they start breaking off from where? So you're not going to use the rattle to tell you how old the snake is. It's just a wives' tale. Now we're going to bring this friendly critter out here, and what I want to do is demonstrate the speed of the strike. I want to remind you that the pit vipers have those really long fangs that fold up against the roof of the mouth. He's going to open his mouth. He's going to rotate the fangs 90 degrees, plus the opening of the mouth makes about 180 degrees. He's going to stab, inject venom, meter it, pull back, and be ready for another strike in a fraction of a second. In fact, it's been clocked on an eastern diamondback at up to 60 feet per second. That's pretty quick.
It's not being as cooperative as the one yesterday.
It'll help if I hold his tail up and anything.
With this one, no, because you'll start thrashing. Yeah.
Let's just put them in a tube.
This one will bite the side.
What is Here, let me get the tail.
Yeah, let's try that instead.
Turn them around this way. Oh, stupid. There we go. You're not going to have any venom left. You keep this up, buddy.
No.
This is a real bets.
I know. It took me half an hour, 40 minutes to catch him in the wild.
Are you saying he doesn't like you?
Oh, I'm saying he hates me. Okay. So.
Also, snakes, one of their defense mechanisms is musk.
Yeah,
Oh,
so
yeah,
this
I
one's
gotta love
musk
I
a
was
little
just
bit.
very happily reminded
Oh, yeah.
of that.
Yeah.
Okay, let go. Let go. I'm going to put you back in here.
Right, so for this one, that's a little bit smaller of a dose, probably because he bit a few times beforehand. Quite thick. The yellow is amino acid oxidase, one of the components. All right.
Actually, in the gland that the venom is produced in, the cells actually burst and to release the venom contents, and so you've actually got a lot of, we call it drag, but just a lot of cellular debris in there from the empty cells. So we'll need to spin that down, and then we'll take off the supernatant so we don't clog up our column.
And we'll be continuing just down the hall here.
Okay, so he's very happy to see me every time. We call him Happy. Because look how happy he is. He's wagging his tail. He wants to see me. See, you could have a pet like this that every time you come in, it wags his tail. I never done. So. Pretty quick, huh? So, in the scheme of friendly snakes that I've showed you, you're probably wondering, well, why in the world would we want to preserve something like this? And that's going to be the topic of our next talk, is just how important these animals are in medicine and pharmacology.